Lesson 6.1.1. How can we model real-life situations with trig equations? Throughout the course of this chapter, chapter 6, we're going to take a closer look at sine and cosine, their graphs, answers, solutions to those equations, more advanced equations and how to solve them, and finally we're going to also take a look at how to represent real-life situations using the graphs of sine and cosine. But we begin with lesson 6.1.1, where we'll be talking about how many solutions there are to these types of equations. Problem 6-1, we begin with a graph of sine, y equals sine of x, and y equals 1/2, shown below. For now, concentrate on the portion of the graph shown between 0 and 2 pi. And in chapter 4, this is where we derived all of our answers. So we're looking at the equation 1/2 equals the sine of x, or theta, or whatever it is we're talking about here. And we're looking for possible values of x. Now in chapter 4, you were taught to use your unit circle. You should have that memorized by now, and try to locate everywhere sine equals 1/2, which if you do have that memorized, you would know that that would be at pi over 6 and 5 pi over 6 on the unit circle. So pi over 6, 5 pi over 6 would be our two solutions. Explain why the graph shows you the equation sine of x equals 1/2 has more than one solution. You can see the graph of sine here, okay, drawn, and then we have the graph y equals 1/2. And just like any other system of equations, where those two graphs intersect are the solutions. How many solutions are there for sine of x equals 1/2 between 0 and 2 pi? How do we find them? Well, there are two solutions, and we've already found them. Now recall the unit circle as shown at the right. The horizontal line y equals 1/2 has been drawn across the circle. Explain how this can help you find solutions to the equation sine of x equals 1/2. So this is unit circle, which means this right here is the unit circle, which means this is 0, that's 1, that's 0, and that's -1 if I'm only talking about y values. Why would I only be talking about y values? Because I'm talking about sine of x, which is always y over r. So I drew a horizontal line at 1/2, and just like the graphical representation, the unit circle representation also gives me the answers pi over 6 and 5 pi over 6. If I was talking about -1/2, then I would do the same thing, except I would draw my horizontal line here. Okay, because that would be -1/2. Using both graph and unit circle, we want to solve the equation sine of x equals -√3 over 2. Be prepared to share your solutions and how you found them. So -√3 over 2, it tells us there is 0.866. So now I'm picturing a horizontal line. At -0.866. Which would be right here. Okay. And I'm trying to determine where on this line those two intersect. And it's pretty evident there that 4 pi over 3, and that's just an estimate, and 5 pi over 3 are my two solutions. I would also know that from the unit circle by locating them on the unit circle. Problem number 2, 6-2, what about cosine of x equals 1/2 over the same interval? How should we draw a line on the unit circle so that we can find where x coordinate equals 1/2? Use this to find the angle that satisfies the equation. So if I'm talking about cosine of x equals 1/2, they still want me to use the unit circle. But since I'm talking about cosine, I'm not going to draw a horizontal line anymore. I'm going to be drawing a vertical line, because now x has to equal 1/2, or the x value. So where is that the case? Well, I'm talking about pi over 3, and on my unit circle, let's see here, this would be 5 pi over 3. Okay? So the difference there between sine and cosine, sine I drew a horizontal line, cosine I drew a vertical line. 6-3. Using the unit circle, explain why sine of x equals 2 does not have any real solutions. How can you come up with the same conclusion by thinking about the graph y equals sine of x? Unit circle, sine of x cannot equal 2, and why not? Because this is -1 and that is 1, so 2 would be somewhere up here. Therefore, the circle and the line y equals 2 never intersect. If I was using a graphical representation, I would have an xy plane. I can graph sine of x, looks like that. And if I drew a horizontal line at 2, that would be up here. And these two graphs never intersect. These two graphs here never intersect, therefore there is no solution. You have just seen trig equations have no solutions. Think of two more trig equations and two non-trig equations that have no solutions. I'd like you to bring those possibilities to class. Now they say no solutions. You could even throw no real solutions in there. That might make your endeavor a little easier. No real solutions. We could always have something like a parabola that does not intersect the x-axis. That would have no real solutions. We could also go as far as having an absolute value inequality less than or equal to a negative number. We know that's not possible because an absolute value can never be less than a negative. I'd like to see some of your examples in class. 6-5 with your study teams or with me, we'd like to solve each of these following equations between 0 and 2 pi, compare answers and techniques. So letter A, we'll begin with letter A. Sine of x plus 1 equals 0. Just like any other equation, you're going to want to isolate the variable. In this case, that will be x, so we have to subtract 1 first. So sine of x equals -1. At this point, you could use your calculator, but you could also use your unit circle. As long as the number that you have here is a number found on the unit circle, that's what I would like you to use. If it's not a number found on the unit circle, then you're going to need to use your calculator, and we'll talk about that as we go. But for now, where does sine of x equal 1? Well, that's only one place. That would be 3 pi over 2. Letter B, 2 cosine of x equals -1. Again, solving an equation. Isolate the variables, so we're going to divide by 2, divide by 2. So I get cosine of x equals -1/2. Is -1/2 a number on our unit circle? Yes, it is. So I do not need a calculator. Where will cosine of x equal -1/2? And I'm looking at, well, if cosine is negative, I'm looking in quadrant 2 and quadrant 3. Okay, and if it's -1/2, that means it's going to be a denominator of 3. So